Hello everyone, this is John Jung. This is Introduction to Data Structures course. Today I will explain Chapter 3 ADT Unsorted List. Let me define a list first. The linear relationship means each element except the first has a unique predecessor, and each element except the last has a unique successor, which means we have a list, in that case some arbitrary list, except the first one, except the last one. In the middle it has the parent and the child. So the parent case predecessor, child is successor. The length is the number of items in a list. The length can vary over time. Also, we have other definitions. Unsorted list is a list in which data items are placed in no particular order. The only relationship between data elements is the list predecessor and the successor relationships. The other item definition is sorted list is a list that is sorted by the value in the key. So key item is used to sort items. There is a semantic relationship among the keys of the items in the list. The key is the attributes that are used to determine the logical order of the list. Okay. So we have the figures, array and the linked list. Okay. So array, you can see array is the element in an array are contiguously. Memory point of view, it is consecutive or contiguously close to each other in memory. So also each array index here, right? So item is located by an index 0, 1, 2, 3, 4, 5, something like that. And the index, okay, 0 means the first one, this one is the sixth one, right? So if we declare integer array, length is 10 case, A0 is the first element and A9 is the last element. On the other hand, the linked list case, memory, the node are linked to each other. So LL pointer point to the first node of linked list, and then the here value and this one's next pointer to point to the next node in the linked list. So we can make this kind of a linked list. So elements in a list are connected by pointers, so they are not close to each other in memory. And also each element can be located by the traverse of a pointer in the list from this front, the pointer, to first node of a linked list. So let me define abstract data type. ADT is a data type whose properties such as domain and operation. Domain is these are variables, member variables. Operations are member functions, are specified independently of any particular implementation. C++ case, I said the domain, member variables, operations are member functions. So data from three different levels. The first one is the application level, second one is the logical level, third one is the implementation level. So first, application or user level is modeling real live data in a specific context. Secondly, logical or ADT, abstract data type level, is an abstract view of the domain and the operations. Okay, so implementation independent. So third one is implementation level, specific representation of the structure to hold the data items, and the coding for operations such as member, okay, method or functions. So second one, logical level is focused on what? The goal. Instead of the goal, the third one is how. How to perform. Like the first one is declarative, okay, way. The second one is imperative way. Do you remember the important operations such as constructor, transformer, observer, iterator? So we will see one by one this class. So sorted and unsorted list. Unsorted list case, elements are placed into the list in no particular order, which means items not sorted. On the other hand, the sorted list case, list elements are in an order that is sorted in some way, either numerically or alphabetically by the element themselves, increasing order or decreasing order, or by a component of the element called the key member. So ADT unsorted list operations we can see transformers, observers, and iterators. Okay, so the first category, transformers case, transform the list items such as make empty, put item, delete item. Observers case, just watching the content of a list, such as is full, get length, get item. The last one is iterator, reset list, okay, or get the next item. So this one is sequentially processed on the list. So what is a generic data type? A generic data type is a type for which the operations are defined, but the types of inside the items being manipulated are not defined. One way to simulate such a type for our unsorted list ADT abstract data type is via a user-defined class, C++ class item type with the member function compared to returning an enumerated type value such as less, greater, or equal. This figure shows unsorted type class. Okay, so within this green box, green circle, we have a yellow box. So yellow box contains private data properties such as length, info. This one is structure array, and the number of the array items is max underscore items, and current position is during the unsorted list operation, current position for in the array. So we have several operations, member functions. Unsorted type is full, get length, get item, put item, delete item, reset list, get next, like constructor. This one unsorted type constructor, and is get length, get. This one is observer, put, delete case transformer, and reset list, get next item is iterator. So this unsorted .h is the specification file. Okay, unsorted .h specification. The CPP case implementation file. So include item type h. Okay, so because item type is used because the private member variable case, the info array is item type is this one is array, the element type. So we define class, unsorted class in C++. Usually the methods are public functions. Okay, so red one, void unsorted type is constructor for class. So this one is used for initialization for the member variables in the class, and is full, get length, get type, get item, put item, delete item, list set, list, get next item. We'll see one step at a time. First of all, class constructor, or special member function of a class that is implicitly invoked whenever a class object is defined or created. So class constructor rules are as follows. Number one, step one, or number one, a constructor cannot return a function value and has no return value type. Secondly, a class may have several constructors. The compiler chooses the appropriate constructor by the number and types of parameters used in the constructor. Thirdly, constructor parameters are placed in a parameter list in the declaration of the class object. Firstly, the parameter list constructor is the default constructor. So at least one constructor should be called whenever creating a new class object. Lastly, if a class has at least one constructor and an array of class objects is declared, then one of the constructors must be the default constructor, which is invoked for each element in the array, which means we create certain number of array of class object. So individual array item constructor is called. So this is unsorted.cpp implementation file array based list. So we first include the item type because the class member variable info, right? List info using an element type is struct element type, and so a void return type is a void constructor, and unsorted type, this is a class name, and this one is scope resolution operator colon, and the same function with the class name unsorted type. This is a constructor. So this is used for class initialization. Okay, precondition none, post the condition is list is empty. So that's why list set. Okay, the length is set to 0 because the length of array based list is 0. Let's move on. Item type class interface diagram, this one. So we have private data for the list, this node. Okay, so the list, okay, item type is we saw, right? So here list item info. So class unsorted list, this includes list item type info. Okay, so this is array. Each item type is item type. Okay, so each item type node has the variable and also public functions compared to print initialize. So this slide shows item type, it's a specifying class. Okay, so include app stream because we call the app stream related. Okay, stream function object is used. So max item for array is 5. Relation type enumeration less equal greater, and item type class. Okay, so item type class. So the value is integer. Okay, value, and public functions including item type constructor for class initialization, relation type compare the constant function, which means that this function cannot change member variable value, and print is a print out. Okay, so standard O stream, this object is used to print out into console, and initialize parameters the number, and return type is void. Next one is item type CPP. So includes upstream file stream and IO input outstream, and include item type previous the slide item type H header file, and then we call this is default constructor. Okay, the member variables functions are scope resolution operator, right, is used with the class name. So this is a constructor to initialize the value. The value is a member variable in class item and type. And then relationship type is we have relation type enumeration, right? So less equal greater. Okay, so compare the two function case. Other item is a parameter. Okay, passing is used, and then value is this object. Okay, myself. Okay, myself. Okay, value class object. The value is compared with the input variable other item value compared. If value is less than other item value, less return. If value is greater than other item value, greater enumerate type. Okay, is used. Okay, otherwise equal. And the print case out stream. Okay, object out is used. Okay, so the value. Okay, just printed. Okay, and then initialize case. Okay, the value is set to number. So this figure shows insertion operation for unsorted list. So the length is currently 3. Three items are valid. Okay, others is actually garbage. Okay, also the length of info array is info is item type, right, element. Okay, so we have max items. So the index starts from 0. That's why the last the item is max items 1 minus 1. The item will be placed into the length location. So we have here so length. Okay, so because valid arrange from 0 to 2 because length is 3, right? So this is the first element, right? So we can put here, and then we can increase the length. Okay, put here. So this code shows insert item. So so insert case, the info array length. Okay, so the length is this one, right? Length this one. Okay, this is to hold the new array item. Okay, so info array length is the index for the this one, right? And then we increase by 1. So that's why increase plus plus. And then we searching. Okay, such as looking at the array items, looking for the IBAN, like a database. We want to search a certain student IBAN. So we start index 0, compare value. Okay, so IBAN is parameter passing value, right? So compare different, right? And second different, third different, fourth different. There is no the IBAN in this list. In the case we return found is okay first. No more case at the beginning we have okay from 0 to 3 case. First one is we can search it. That's why more to search is value is true. And secondly, we increase the index right by 1. No more to search is true. Found is still first. Location is index. And then location 2 and also different even and set different, right? So okay, we can okay search more, and the found is still not found. So first location is current 2. So okay, so we okay. This one is still the index less than the length of array info, right? So true found the first, right? Because compare your different value, located 3, and then we increases the some location 4. Location 4 is out of valid okay range of info array, right? Because we have 4 items in the array. So in that case, more to search is set to first. So we can say there is no such even item in the list. Okay, this .cpp unsorted cpp includes get length. Okay, just return member variable value. Unsorted is full case length and the max items is compared. Okay, so max items is the possible the items to be inserted in the array list. And then the get item case item, okay, and found. Okay, so the item is the passing. Okay, the get item. So okay, so found is initialized first because we didn't find yet. More to search case location. Location currently 0 first okay index of info array, and length okay is actual the array length, right? So this is less is true, right? So this one is true and not found, right? So first this negation not operation apply this value first. True, right? So in that case we can compare. So the item, okay, the item compare. The item is we want to search certain value of item, right? So this one called an info array location the item compared. Okay, so value is compared. We saw it before, right? The last case, greater case, equal case. Greater case with location increases. Okay, and then okay, less or greater case we can perform index for searching location increases by 1. No more more to search case location still less than length means still we can search remaining array items. And then you can see this one not applied, right? So let's equal case found true. Okay, and then item info location okay is locate the item corresponding to this input item, and then break and then return this one. Okay, so from now on we'll see the deleting broadly from an unsorted list. So here we have array info array, and then we location is start 0, and then we can find play and then delete. The strategy, the last item is copy into this. Okay, play the item, and then we can reduce the length by 1. So we can increase location compare. So we found key Bradley has been matched. So the last item, the H thing is copy, and then so we reduce the length by 1, right? So this value okay becomes okay 3. So to place the copy of a last list item into the position where the copy Bradley was before. So and then the length is okay, becomes okay 3, and the location is 1. Okay, copy the value. Okay, decremented the length of the class. So let's take a look unsorted .cpp delete item case. We want delete this item. Okay, so location is 0. We can start the first the element okay in the unsorted list. Okay, and then this item compare the array, the location first one, right, and the equal or not, right? So not equal case, keep going, and then we found, okay, if we found the value, and then that is the location. Okay, and then so info length -1, right? So the last one is a copy into this one. Okay, the length is minus. So if actually we try to delete this item, but there is no such kind of item case, this location increases. Okay, increases. Okay, so search. Okay, so location is increases. Okay, but here we are assuming the deleted item exists. Okay, if it is not the case, right? So in that case, the comparison is or is not equal, and then this value okay, the increases and increases. Okay, we can go to okay increase by keep going. Okay, keep increases. Okay, but the problem is we also consider the upper bound of array, right? So because if item doesn't exist in the array case, we just compare, there is no, right, such case, and then it can over the length of array, right? So in that case we need to some the check the okay the boundary of array in info array, and then we can okay we can control, right? So in that case, if this is upper index is last one case, this one is okay, just this one is the last one, this is the last one, right? The last one value is copy into last, and okay, length one copy, and -1 case actually reduces. Okay, so in that case the length is reduced. So this makes some what we didn't expect. So the assumption is the item should exist in the info array. And the unsorted list case current position to search, right, is set to -1, means actually there is no element in the list. And the next case, current position is the increases by 1, and then we can return corresponding info array item. This one is copy and return item type. Okay, next topic is what is a pointer variable. C and C++ pointer is very important. A pointer variable is a variable whose value is the address of a location in memory. To declare a pointer variable, you must specify the type of value that the pointer will point to. So this okay symbol is pronounced as a asterisk. For example, integer int, we can say asterisk. PTR is PTR will hold the address of an integer type variable. And character star, okay, we can simply star or asterisk. Okay, Q is okay, holding the address of a character type variable. So using a pointer variable, okay, int x is we declare variable x integer type, and then we initialize the value 12. And then the pointer int star ptr, this is the pointer variable. So and then this variable can have the address of variable x. So ampersand, this one indicates the address of this variable x. So we declare the ptr, we make this green box. This memory cell's address is 3000. Okay. On the other hand, x we declare here, it create the variable. The address is 2000. So this assignment means the variable ptr, the value is the address of x variable. Okay. And then we have a unary operator. This okay, asterisk is called the reference operator or in direction operator. So which means the reference means accessing the value of a variable by using the address of the variable. Okay, so which means we have this x declared initialize set to okay 12, and then ptr we can declare, okay, we make this one, the address of the ptr variable is 3000, and then this assignment ptr set to ampersand x is this box can contain integer, okay, the pointer, okay, address. Okay, so this value contains x's address. Okay, and then standard out we print. Okay, so this one star ptr over the asterisk ptr means the value of a variable pointed to by the pointer variable ptr. So the reference okay means accessing the value of a variable like, okay, so the x, okay, x value 12 is printed using x, okay, address. Okay, so this one is ptr, okay, star means, so we can point to the value of 12, okay, because ptr value is 2000, point to this cell, and then the reference operator asterisk indicate the value within this box. Okay, so note the value pointed to by ptr is denoted by asterisk ptr. So using the reference operator star over asterisk, okay, so we declare variable, we can initialize value 12 for variable x, and then we declare pointer integer of pointer variable ptr, and ptr set to ampersand x, the address of a variable x, and then the reference, okay, this one. Now, so ptr this one variable, okay, left hand side, this is like the reference case indicates the variable, okay, and then the variable, the value set to 5 means previous 12 is overwritten with 5. Okay, and another example case, a character pointer. Okay, so character, okay, variable ch set to alphabet capital A, and then we declare the character pointer q. This one is points to the address of ch. Okay, and then q okay, asterisk q set to g means the cell value, ch cell value is okay changed with G, and then character star P, we can make another pointer variable, and P set to Q case. This P value is the address of CH, this cell's address. Okay. So C++ data types. We saw a simple integral, so simple data type: character, sort, integer, long integer, enum, enumeration, and plotting case: plot, double, long, double. On the other hand, the structural type is array, struct, union, class. Okay, the address case: pointer and reference. Okay. So dynamically allocated data. So we declare character pointer PTR. So we can create this box. Okay, this box, inside box value can contain the character variable address, and then new function. This is an operator that allocates the memory of a variable dynamically. So variable, unnamed variable is created, and then PTR can point the unnamed variable, and then PTR the reference left hand side is the variable pointed to by this PTR, and then value is initialized with the character B, and then we can print out standard out stream. So the reference PTR's star PTR means the value pointed by this PTR. Okay, so on this one PTR, the reference star PTR case, PTR value PTR, the reference here, the value set to B, and then we print out B. Okay, so now we delete the PTR. So if we print out B, PTR print out, right? So and then we delete PTR. So note, delete is an operator that deallocates the memory pointed to by the pointer PTR dynamically. So yes, but what does new do? New takes a pointer variable, allocates memory dynamically for it to point, and leaves the address of the assigned memory in the pointer variable. If there is no more memory, the pointer variable is set to null. So null pointer case, this is a constant. So this one is available in CSTD depth. So null is not a memory address. It means that the pointer variable points to nothing. So usually we declare a pointer variable, we can set to a null. If it is an error to the reference pointer whose value is null case, we cannot access null pointer value variable. It is the programmer's job to check for this. While PTR is not null case, we can process within the while. So to use the reference PTR here. Using operator deleter, this one is a delete the class object created by new. The object or array currently pointed to by the pointer is deallocated, and the pointer is considered unsigned. The memory is returned to the free store, which is managed by the operating system OS like Linux and Windows 11. Square brackets are used with the delete to deallocate dynamically allocated array of classes, which means if deleted variable is class array, we should use square brackets. So what happened here? So this code, take a look. Integer object is created, and the PTR point the address of the integer variable, and then we can set the integer unnamed variable value is 3. So like ptr address point in direction or the reference here, and the value set to 3. And then a new int we make, okay, and then the value is okay, this one. So previous one is here, new one. So this is actually a memory leak happen because it cannot delete. So not to prevent such as a memory leak, we should delete the memory pointed to by a pointer before we make the pointer to point another variable. So basically, if we point another variable, previous one should be delete like this. Okay. So memory leak. Okay, let me summarize. Memory leak occurs when dynamic memory that was created using operator new has been left without a pointer to it by programmers, and so is inaccessible. So we can make pointer new int we can make new has this one is pointer this new allocated integer unnamed variable, and this is a set the reference variable the set to 8. In the same way, we create new integer named variable and the ptr2 set to the address of this named variable, and the reference asterisk ptr2 case this pointed variable value set to -5. Okay, how else can an object become inaccessible? So causing a memory leak. Okay, so int star ptr new integer here. Okay, this situation, right? So new int case created this memory ptr. This initialization is this ptr cell value is the address of this unnamed variable containing 8. And ptr2 case we make another one and we initialize -5 here. Okay, so in this case we set update ptr variable address value is set to ptr2's address value, right? This one, so it both a point, but this one cannot be accessed. So it is called the dangling pointer. Dangling pointer occurs when two pointers point to the same object and delete is applied to one of them. Okay, so you can see we create new int here and a new int here, and so ptr new int case this one is initially points to this unnamed variable containing 8. Similar ptr2 case also points memory cell unnamed object contain the value -1, right? And then ptr this inside the value address value set to ptr2 this one. So in that case this one both point. So and then if we delete this one, so the delete this one means the pointed variable this one is actually deleted. Deleted case the ptr this one is point to the deleted some memory object, right? So this is called the dangling pointer. Invalid address is set to for ptr. So leaving a dangling pointer, this one is summarize. Summarize is the memory leak and dangling point. So here we new int is we make and then initialize this value because this point this one, and the ptr2 case create this -5 value is contained this variable created new, and then the reference ptr2 case this point. And then here with the delete ptr2 case ptr2 value point to this one, this node deleted. And then this is set to 0. The value local variable ptr2 is null, means it doesn't point to any cell, valid cell. But PTR, you point to this one. Okay, this one is actually the allocated one, freed memory. So this is the dangling point, because point to invalid memory cell. Okay. Remember, a list is a homogeneous collection of elements with a linear relationship between elements. That is, each list element except the first has a unique predecessor parent, and each element except the last, the child, okay, the successor is a child, right? Except the last has a unique successor. But first one case doesn't have any predecessor, last one is doesn't have any successor. So ADT unsorted list operation. So we have three kinds of operations: transforms, observes, iterators. Transform is change the content of item. Observe just observe the member variables in the class. Iterate case, the set, okay, the position of the iteration position value is set to -1, which means the list is kind of we didn't iterate. Okay, get next case, we can, during iteration, we can get the next item. So this figure shows unsorted type character with a linked list. Okay, so unsorted type data type is character. So in that case, private member variables is length. List data is a point to the first list item. Each item next point to next, okay, successor. So the last one is pointer value set to null, indicate this end of the list. And left hand side we have constructor make empty, destructor unsorted type. This constructor case, the tilde and the class, okay, name. Get item, put item, delete item, and so on, and then get next item can be implemented. So remember, this one is a linked list based on unsorted type, the unsorted ADT list. So B character inserted unsorted list case. So this is the current situation. Okay, so length 1 to 3, length, the list item is 3, and list data point to this is the latest added item, but current position not doesn't be okay, doesn't do anything, because list data is a point. Okay, this is not index, because memory, this node not contiguous, so they can okay, close to each other. Okay, so now we want to add item B, right? So we create node type. So this is a node type. Okay, so value, and this is the next pointer to next node type. Okay, so node type create, and then local variable, the point to this one, and then this value location info, okay, set to item, this one. Okay, so the item is we assuming this local variable item value is B. The B is a set like this. Okay, and then so we can operate the next pointer of this node, right? So the location next is this one. Okay, this pointer next. Okay, and the list data is this first node in the list, right? This is the operation, and then after that we insert this one, and then the list data is point to the latest inserted node, right? So, and then we can make this kind of list, right? So list data is updated with the node containing the value of B character. And also the length also we can increase it, because we unsorted list case, the length indicate how many node in the list exist. Okay, so we increase this by 1. Let's take a look on sorted H. Okay, based on node type. So node type is struct. Okay, so unsorted .cpp okay, define the structure, okay, of a node type. So the info, okay, is the item type, and next is the node type's pointer. So the class, okay, we can define, okay. So unsorted type, so public some operations are okay declared, and then private case list, okay. So node, okay, type, and then the node type inside is item type. That's why we have some angular bracket and then the item, and then star means this is actually the reference, okay. So point to the first item in the unsorted list. The length is the number of valid item in the linked list for unsorted ADT, and the current position is during the list operation, print out some items. So current position also node type pointer. So do you have to keep a length field? Probably not, right? Do you need on is full? Okay, so problem not. Okay, so here the length case, but we have okay count the number of 1. Otherwise, we can actually iterate, traverse from the start of linked list and then going to last node. Last node, next the point is null, right? So we have a count every time. So that's why the length field indicates the size of unsorted this list. Okay, length can be easily found. List data is not initially because there is no data yet. So get length is return, okay, member variable length. And then let's take a look unsorted CPP. Unsorted type get item is okay, we want to get the okay the array item having the same value with the item, and boolean type pond is used. This is the reference. Reference case is different from on pointer, so we can see just the similar the role of pointer, but it doesn't require okay the reference okay pointer, such as asterisk is not used. Okay, so the okay role and function is similar to a pointer using this reference type, but operation case it doesn't require the reference operator asterisk. Okay, so here more to search, and the location is a current location for search. So list the data type indicate the first okay location of node found first because we didn't found yet. And the more search location is not null case, we can keep going here. So more to search, this found is initial force, right? True, right? And then so item, we want to find some item within unsorted list, right? So item location, the info current location, the same case we matched found, and then location info is copied into item and return. Otherwise we can iterate. Location next is set to this location, so we can move to toward the end of list. More to search case, location is null case. Okay, we can keep going. Okay, otherwise we can stop. Okay, and the unsorted put item case, we can insert this one. So the location we is set to new type, node type, and then the value is set to this one, and the next is current, the start node of a list. Okay, so the list data pointer, the current start node, and then local next is point the start node, and the start list data is set to the latest inserted node location, and then we increase the length by 1. Summary, we learned an unsorted list as an abstract data type ADT. It is called the ADT unsorted list. This list supports several operations such as create, determine, put, get, and delete. We also studied the following test plan for an ADT: declaration and access of variables to which pointers point. And also we saw implementation of the list operations. And finally, we saw 2 ADT unsorted list implementations, such as an array-based list and a linked list. Okay. In the next class, we'll see the ADT sorted list. So thank you for your attention. If you have any question or comment, please let me know. Thank you.